Okay, so some background on Adobe I/O. We started as many companies do, hosting APIs for customers to access different Adobe products from their desktop creative suite to their enterprise applications like AEM and Target. And then eventually we added the Adobe I/O console, which enabled developers to create integrations. And these are similar to something like Facebook apps, which most people are a little bit more familiar with, where the developer can create a workflow where users grant authorization to creative assets and data, and then the application can perform processing on those. To create these kind of integrated apps to stitch together workflows at customers' applications with Adobe products. And then we added Adobe I/O Runtime, which is the serverless platform where now, in the best case scenario, the developer doesn't need to host the app anymore. They can construct the app using functions within the serverless platform. So why would we do this? And the answer is not to compete with things like AWS Lambda or Google or Azure. It's so that we can provide Adobe customers with an Adobe-based platform. Customers don't need to care about cloud infrastructure accounts or anything except for their Adobe products. When they buy Adobe products, they can gain access to this extensibility engine, and they can stay within the Adobe ecosystem for the lifetime of their application. And the other reason is so that we can provide custom environments. So we can do things like run custom images or custom hardware or whatever we want. So we can do things like create Photoshop environments that become serverless endpoints that customers can remotely control. So a little bit of background on the architecture of Adobe I/O Runtime. We're using Apache OpenWhisk, and we like OpenWhisk. It has a great community, has a consistent, simple, stable set of APIs. And one of the really nice things about OpenWhisk is it's a turnkey system. So if anybody's thinking about leveling up from hosting APIs to hosting a serverless platform, you can take OpenWhisk and drop it into your infrastructure environment and have a serverless solution dedicated to your customers in a relatively short time frame. We went GA in June this year. That's going well. It's currently used by a couple of different types of customers. One is third-party Adobe customers. And these are folks like Yamaha and Microsoft, where they purchase Adobe enterprise products for hosting CMS systems, doing data analytics. And then we have Adobe teams, and these are first-party internal Adobe folks that are using the runtime system to build features that aren't directly exposed as runtime to customers, but they are providing extensibility through some custom add-ons to their products. And some examples there are Adobe Experience Manager and Adobe Target. So I want to talk a little bit about some use cases that we are going after supporting within Adobe and for Adobe customers. In general, we try to support all the use cases. This doesn't work everywhere, as Evan pointed out. There's some cases that just don't slot into serverless great, but some examples that we're supporting today on the extremes are large memory footprint, long timeout type of functions, require lots of disk space, limited concurrency where they have to operate in basically a single-threaded model. And a common case for this is something like image processing or video processing. We have teams doing this. And on the other extreme is low memory footprint, low latency, high concurrency. And these are things like user-facing browser applications where latency is the name of the game, and keeping things fast and reliable. And this is also a similar concept to running functions at the edge. So wherever you have content delivery networks and you want to make those that content more dynamic, latency becomes really key. And then everything else, we kind of bucket into this generic use case where it's a deployment replacement for microservice deployment. Instead of building an application and running it as a microservice, now you can build a function and still access it and treat it from the outside as a microservice effectively. So while we've been building Adobe I/O Runtime, things have been going on outside of Adobe, and a few of those things that are kind of interesting are things that folks at Cloudflare are doing. Knative, everybody I'm sure here is well aware of Knative. And OpenWhisk is evolving constantly on its own. So I want to talk about some of these evolutions. So Cloudflare is kind of interesting, where they take V8 isolates and effectively run multiple functions inside of the same process. And this is kind of interesting because it adds yet another layer of scaling to the system, where we've talked about scaling not at the VM level, but container level for a long time. Now we're talking about scaling inside the process, inside a container on a VM. So they're adding new low latency ways to scale for, they primarily deliver for the functions at the edge type of use case. Knative serving is a good candidate for things like general purpose processing, where we have one function per image, one function per container. We can scale it out on a system that is good at running containers, Kubernetes. And we can use Kubernetes primitives for handling how that scaling works. So it looks from the outside potentially similar to how we handle our microservices that might be running on Kubernetes also. And then OpenWhisk has evolved on its own. And some of the interesting things that happen within OpenWhisk are the ability to create more complex workflows like sequences and compositions, where you can take multiple functions and stitch them together and treat them as a single unit of work and have the system manage the state that is transitioning in between each element. And while serverless has evolved technology-wise, API gateways and approaches to API gateways have also evolved. And specifically, a lot of us are following the evolution of Envoy, and it has some interesting features that are potentially really handy for a serverless platform. So these are things that I would just rather not do in OpenWhisk if we don't have to. So things like authorization and rate limiting. These are boilerplate functionality that is required by any serverless platform or any API gateway in general. And so why should we handle that in the serverless platform? It would be great to use Envoy for that. So if we look at things from a use case perspective, what we'd really like to be able to do as a serverless platform operator is to be able to use the right tool for the right use case. So for latency sensitive services, where performance is really key, it would be great to use something like a V8 isolate type of approach, where we get a lower startup and initialization cost. For general purpose microservice scaling, it would be great to just rely on Knative for doing that, because that works well with Knative serving. For complex function workflows, we're using OpenWhisk for that already. We'd like to keep using OpenWhisk for that, because OpenWhisk does that nicely. And then for consistent handling of ingress, Envoy is coming up as a leader in that kind of space. And so we'd like to be able to just delegate all of that type of functionality to Envoy. So before I go into talking about how we can apply those technologies, a little bit of background about OpenWhisk architecture. I won't go too deep here, but just some basics. So the basic operational components in OpenWhisk are the controller and the invoker. And the controller is the kind of ingress portion of the system where both function developers and function users arrive within this component. And the controller handles both the CRUD operations for developers and the invocation workflow for routing to an invoker component that does the actual container and initialization and function management. So what's interesting here is that right now the controller handles both the data plane and the control plane ingress. And the invoker is focused on container management. So some keys to, if we go back to thinking about the different technologies, if we think about how we can apply those, one of the keys is separating these planes in OpenWhisk. So getting away from having a central place where both the data plane and the control plane have to flow through. We also want to be able to delegate the ingress features. So taking some of these features out of the controller and leveling them up into the ingress gateway. We want to be able to delegate execution. So instead of forcing everything to be executed inside of OpenWhisk, we want to be able to choose either declaratively or dynamically so that the right execution environment for the function at the right time is what's used. And they also want to normalize the process so that what a developer sees from the outside looks the same no matter what execution environment they're using. So, this is different than saying, well, just tell people to use Lambda or Knative because it looks different when you're using those independently. So we need a way to normalize that usage. So going through each of these, first separating the planes, this is pretty straightforward. We're just separating out the OpenWhisk controller to be dedicated to our control plane. And now we have a new component. This is the OpenWhisk router. And this is going to be dedicated to our data plane management for this system. So most of my talk will be more focused on the OpenWhisk router point. So if we look at these in detail, the control plane stays as is, and the data plane is now provided by the OpenWhisk router. And it's going to be a dedicated data plane controller. And what do we need to do to get there? Well, this is a brand new component, so we are working on building that. And we're also building execution providers for different types of solutions. So OpenWhisk and Knative and V8 isolates are the kind of primary cases that we're targeting right now. And then really to be able to optimize the system for reuse, we want to allow the system to have its own notion of resource allocation that's independent of the execution providers, but available for these providers to use so that we can maximize the reusability of containers. Because ultimately, when we're talking about scaling to zero and then continued traffic, the reuse becomes the key component to minimizing latency and avoiding those cold start type of situations. So next up in our technology keys is the ability to delegate ingress features. So what we're doing is taking the ingress functionality that's currently baked into the OpenWhisk controller and moving that out into our Envoy gateway system. And this just simplifies the controller and the router, and it also makes it so that we can use the same system now for both our serverless platform and our API system, so we can leverage the same authentication, rate limiting features. And we can do that with Envoy by using some kind of off-the-shelf functionality. For authorization, there's the external authorization filter, where we can provide a dedicated service for authorizing requests. That applies to both the control plane and the data plane. And same with the rate limiting, where there's a rate limiting filter that we can use for that. One of the features in OpenWhisk that we want to keep parity with is a concurrency-based limiting, and this is similar to what the experimental adaptive concurrency filter in Envoy provides. So once you get into the OpenWhisk router, getting to the point of execution becomes a workflow in mapping the function to a particular execution environment. And within the OpenWhisk router, we have this logic that is able to map the function to the appropriate execution environment, either by defining annotations on the function or by specifying as part of the request, giving it hints, if you will, to see which execution environment is appropriate for those function calls. So if we look at an example kind of up close, Knative is kind of interesting for this, where really in order to use Knative in this way, we move away from the notion of one function per image in Knative, and we are more in line with one function per Knative service, and really the function allocation to the service is done lazily. And in OpenWhisk, this is a concept of stem cells that helps avoid those cold start times where we start the Knative service or the pod or the container ahead of time, and then the code for the actual function is injected lazily whenever traffic starts for that particular function. So we have a workflow that looks like this, where before traffic, we create some general purpose Knative services, and you can think of those as stem cells. And then when traffic begins, we start by allocating a specific service to a specific function, and then we just start routing traffic to that function. And of course, within the Knative space, the function doesn't exist there yet, and so the container that's actually running needs to be aware that it needs to install the function. And when traffic increases, we scale the service, and we end up with additional pods. And those pods get the function installed. So if we look at this visually, it's a little bit simpler. So we have the OpenWhisk router on the left side here, where step 0, so basically when the router starts up, we allocate some stem cells, and these surface in Knative as separate services that are unallocated. And then step 1 is we get a request to handle function 1, and the first step for that particular function is to allocate a particular service. So we're in this case, we're allocating service 2, and we start routing that traffic to service 2. And within Knative, the life cycle of the function goes into play, where that service instance now, each pod will get the function installed on its first use. So for normalizing the input and output of the system, what we're looking at is this type of workflow where on the router side, we can transform the incoming request and we can transform the response so that the developer's dealing with one system, the Adobe serverless system, and they're not dealing with whatever different types of execution environments that we have. So the developer doesn't need to know any details about Knative or Kubernetes or V8 isolates or OpenWhisk. They just need to know the APIs of the Adobe Serverless platform. And either they can choose, we can allow them to choose, or we can choose for them what execution environment they use. But we handle the request and the response in a consistent manner. And this also becomes really important for logging and metrics so that we can consistently handle things like monitoring, billing, where we want to be able to have a consistent view of the system. So just a quick summary of what is involved with the OpenWhisk router. It's similar to a proxy, but it's not exactly. It's a little bit more than that. So some of the requirements are providing a data plane API for function execution, resolving functions to execution environments, request response normalization, and providing consistent metadata per invocation. So whatever we do for developers on a per invocation basis needs to be consistent across all of those environments. Providing state management cache, and this is really getting back to the giving different types of execution environments the ability to optimize resource reuse so that we can steer folks to the best possible path for lower latency. And whenever we're dealing with resource allocation, on the flip side, we also have to deal with resource cleanup and garbage collection. So just to call out some negative requirements, so things that we are not wanting to do. So we're not using container primitives in this particular component. This is just for managing resources and delegating execution to the execution providers. And we're not using static routes. So we don't want to end up with a routing table that has the route per function type of map in memory with millions or billions of different functions that are changing at the whims of our developers. And this routing is loaded dynamically on demand, and it changes constantly. And then some potential features that we can add at this layer of abstraction are things like streaming, where we don't really allow users to connect directly to containers today, but we could allow them to connect to this router and proxy that streaming behavior into the container. Whether or not the execution provider supports it doesn't really matter at that point. And some other interesting things that we can do are things like outsourcing burst processing. So if we get up to cluster capacity or whatever we deem is too much to manage in our cluster pool, we can either delegate to other clusters or even outside cloud providers like AWS or Azure or Google. So the current state of the OpenWhisk router, it's a prototype coming soon to the OpenWhisk core repo. If folks are interested in this, I encourage you to tap into the OpenWhisk project. It's an Apache project. We're on GitHub and Slack and the usual places. Thanks for listening.
All right, any questions? So how does the deployment model work? Because the way you deploy code to OpenWhisk is different, and the way you do to Knative is different, right? OpenWhisk, I believe, it stores the code in a document database, and Knative requires a Docker image. So that is also handled by a separate component?
Yeah, so this is kind of what I was getting at, where OpenWhisk provides kind of a turnkey system that includes an API for deploying code. And it's true that today that code is stored in a document database, but what's important for the developer perspective is that there's an API for injecting a blob of code into the system.
Right.
Any other questions?
Hi, good morning. What sort of tooling do you provide to developers to interact with the platform? As in, to make it easy for them to actually develop these functions? Do you have some sort of local environment for that as well, or how do you handle that?
So tooling, I think, is a sore spot across the serverless platform spectrum, including Adobe I/O Runtime. So from an OpenWhisk perspective, the tooling options available are there's a CLI, there's the API, there is a debugger, and there is a kind of functional prototype of a composition visualizer. So it's getting better. I think one of our colleagues built a debugger that's very cool, that I think really closes a lot of that gap. There's also a browser-based editor that was recently built by another company called Nimbella. So it's, it's not as broad as desktop development or probably some of the tools that you can get with Lambda, but it's growing and the gap is closing.
Thank you.
Any other questions?
So with the Knative execution, you have specific containers for Java, for JavaScript, and so on and so forth. Is that how it works?
Yeah, so the notion of using stem cells requires that you have a fixed, set of runtime environments that you support. So we skipped some of the challenge on our particular product by only supporting Node.js most of the time.
Java would be quite challenging there.
But Java has its own set of challenges for getting dynamic code into a running container.
Could you explain your point about static routes? I didn't get it.
So in general, a lot of systems today work by having whenever you add a function to the system, you have a route in the system. And OpenWhisk doesn't work that way, and that's one of the things that I like about it, is because you can have a infinitely large set of functions in the system without having a crazy huge routing table that's constantly changing. Because when you're dealing with operating the platform yourself, you have to deal with all the notion of changing the routing table constantly whenever somebody changes a function. And so we avoid that case completely by only loading the routes on demand.
All right, thanks.
So there's no retrying, there's no changing the routing table.
Okay, I think I have time for one more.
Yeah, I just wondering, you talk about one of the potentials to support streaming functions, I guess. Could you, elaborate a little more? Do you have a use case for this?
Not off the top of my head, although every once in a while, one of our customers asks us if we support things like WebSockets, and where they want to have a persistent connection that is fed multiple responses for a single function, things like that. And when you have a serverless model where you're delegating the lifecycle away to a provider that intrinsically wants to scale things to 0, you can't maintain a connection there. And so this is a type of way to address that type of problem.
All right, and with that, I think we're done. Thank you, Tyson.
Thank you.
Yep.